Welcome to solverfy.
Okay, so we're going to draw structures and then determine if these structures are optically active. Starting first with 3-bromohexane. So I'm going to start with my hexane. I'm going to go to the third carbon, and I'm going to draw my bromo group. Okay, so now we need to determine if this is optically active. And the answer to that is yes, and we can tell that it is because this carbon right here is going to be optically active. And we know that because it's bonded to a bromine, a hydrogen, an ethyl, and a propyl. Because of that, it's got 4 distinct groups and it has a chiral center. All right, so moving on to B, we have 3-chloro, 3-methyl pentane. So starting with the pentane. Okay. So 3-chloro, 3-methyl, meaning we're going to have 3-chloro, 3-methyl here. Now this is actually not going to be an optically active molecule. Now you would think that the carbon at the 3 position would be optically active because it's bonded to 4 groups. Now what you need to kind of remember is that 2 of those groups are identical, right? It's bonded to a chlorine, a methyl, and then 2 ethyl groups. Since 2 of those groups are identical, that means there are no chiral centers in this molecule, and therefore it is not optically active. All right, and then moving on to C, I've got 1,2-dibromo, 2-methyl-butane. So just to draw my butane to start, I've got 1,2-dibromo. So 1,2-dibromo, 2-methyl-butene. So 2-methyl. I'll draw a methyl group right there. Okay, so now we need to say, is this chiral, or are there any chiral centers? The answer to this is going to be yes. Again, you can kind of say that that middle carbon, the second carbon right here, is going to be chiral. And the reason you can say that is because it's bonded to 4 different groups. It obviously has a bromo group immediately off of it. It has a methyl group immediately off of it. And then it has an ethyl group, and then a bromomethyl group. Since those are all 4 pretty distinct groups, that must be chiral, and therefore is optically active.